morning, Algebra 1, periods 1, 6, and 7. It's Friday morning. It's Mr. Mays here to bring you another exciting installment of Chapter 8. All right. Hopefully yesterday you saw the notes. I put up all the solutions for the problems in section 8.4. It got a little long, but anyway, I posted them up there. I typed them. You can actually read them. That's kind of cool. So today, I want to do section 8.5. I'm going to post some stuff up there. But before I get started on that, this is Friday. It's April 3rd. It's the end of week 3 of this fun and game we've all been playing. And I would really like to take this opportunity to thank you for participating at the level that you have. Some of you are doing just an absolutely awesome job. You're getting stuff turned in. It looks good. I'm pretty happy about that. Sometimes they are a little difficult to read, and I just have to kind of give you the benefit of the doubt that says, hey, I think they have it right. But please do refer to the answers that I do post out there. Compare your work with what I put out there, and that way you'll know for sure that you're getting it right, because I cannot always read your writing. Imagine that. All right, so again, a big kudos to you. Thank you very much. Most of you are doing an awesome job. Got a few holdouts, but not near as many as what we had. So without further ado, I would like to roll into section 8.5 and introduce a new concept. So here we go. Yeah. Oh, yeah. Here, let's try this. Okay. Good morning. 3 April, section 8.5. It's called intercept form. And it looks kind of like this. It says that if f of x is equal to a, and we'll talk about a little bit later on here, times the quantity x minus p times the quantity x minus q. And P and Q are just simply values. An example of what that might look like. Here you've got f of x is equal to a. Again, we'll talk about that later. X minus 4 times x plus 3. Okay? They just put some values in there. They don't always have to be integers. They can actually be fractions and other weird stuff. But anyway, for right now, let's stick with that. All right. Now, the A can be a tough nut to crack, but here a little later on today, I'll show you how that's done. So let's look at an example. So you may have an example like this, and it'll say like this. It'll say find the zeros. Now, zeros. All that means is you're finding the spots where it crosses the x-axis. So terminology that's going to be interchangeable in this section. Zeros. It'll say solve when y is equal to 0. It'll say find the x-axis intercepts. It all means basically the same thing. We're trying to find where something like this crosses the x-axis. Now, notice that the a is not there. It's implied to be a 1, because that's what I want to start with. Now, you all know how to solve this. You take each individual factor, you set it equal to 0, and in this case, x is equal to 3, and x is equal to -1. So we found the zeros, or we found the x-axis intercepts. You know, they can ask for the same thing in several different ways, but that's what we're trying to find. We're trying to find a place where it crosses the x-axis. In other words, when y is equal to 0, what are the values of x that make that true? Okay, set it equal to 0. All right. Okay, so now I took this a little bit step further. I decided to go ahead and graph this, so I put those values on there. I mean, I found those. When you set that equal to 0, those are your solutions. So there are the 2 points on the x-axis, okay? Well, now there's something that I really want to highlight today, and that's this axis of symmetry. Notice that the axis of symmetry is, in fact, halfway between the 2 x-axis intercepts. Yay! Well, I know that the vertex is on the axis of symmetry. So if I know the x value, if I know the equation of that axis of symmetry, which looks like, hey, x is equal to 1, I can take 1 and plug it into my equation, and I can find the y value of the vertex. If the axis of symmetry is equal to 1, put that 1 in for x, like that. And sure enough, y will equal -4. So now I can graph the vertex. Ta-da! Now you see that point right there? That's the y-axis intercept. How do you find that? Well, the y-axis intercept. if x is equal to 0, because every point on the y-axis has an x value of 0, if you put a 0, if you take that 0 and you put it right there and put it right there, you will find that y is equal to -3. So put that dot on your graph. Ta-da! Now remember, it's symmetric. You're 1 to the left. At the same y value, move 1 to the right. Put that dot there. Now you have 5 points. You can graph this parabola. What an awesome thing. All right, so more to follow on how to find A. Anyway, it's Friday. It's the 3rd of April. And we get to do parabolas. What could be more fun than that? All right, May's out.